It's nice to have you here again with us. Today, we are going to be looking into the travel demand modeling in transportation. And here, we're going to be looking into the concepts involved and also the four steps involved in travel demand modeling, that is, the trip generation, the trip distribution, the mode choice, and also trip assignment. But before we go into that, let's try to break this down. We have the travel, we have demand, and we have modeling. Now, when we talk about travel, we know is the movement of people within a distant geographical location. So when we see people moving from one location to another location, we can say a travel has occurred. And this can be done by various means. It might be by walking, by driving, flying, sailing, and it can be a one way trip or it can be a round trip. And and also people tend to travel for different reasons. It might be for business, it might be for work, it might be for leisure, it might be for maybe other personal matters. So that is the concept of travel. We know it's the movement, like this, the movement of people or the movement of people within a distant location from one place to the other. So that will come in handy when we go into the concepts fully. Then the demand is talking about the need for something. There is a need for something. When there is a need, when there is a gap that needs to be filled, then that means there is a demand. So, and when we look into the concept of modeling, the act of creating a representation of something, and maybe it might be in form of a physical object, or like in the case of what we are going to be looking into today, a mathematical concept, then we can say a model has been established. That is, it's all about a representation, creation of a representation of something. But in transportation engineering, or what we're going to be looking at today, it is more like the the creation or the representation of a mathematical concept, that is modeling. So we are going to the combination of the travel, like I explained, the demand and the modeling in transportation is what we now call the demand traffic modeling. So here we're going to be looking into the broader concept of it. Now, when transportation planners, when they try to forecast the future travel plans or the future travel patterns and understand how people move around within a region, now that process of that study or that process of trying to forecast the movement or the travel pattern is what we call the travel demand modeling. The important concept here is that it entails a process in which we talked about, and we're still going to be looking into in later in the slide or in the video. Now there is a process that are involved. That is when we have the trip generation, the trip we have the trip generation. We also have the trip distribution. We have the choice of mode and also the trip assignment. Now, all these processes, when a transportation planner tend to use all this in order to be able to forecast travel patterns. So, what is the travel pattern like? Having this information about their trip, being able to use that information to be able to predict the future travel patterns and understand how people will move within a certain region is now what we call the travel demand modeling. The ability to be able to draw up that computation from what we said about modeling, ability to be able to come up with that mathematical model for that representation is what the travel demand modeling is all about. And we can see from the slide here, it says that it's a computational framework to predict travel patterns based on land use, the demographic and infrastructure. So we need to also be able to understand their use, the land use, the demographics, and also the infrastructure. And the question most people can tend to ask is that why do we need to actually study people's travel pattern and to be able to predict future travel patterns? All this is quite important because of it helps to be able to predict future traffic for infrastructure planning. If we notice that within the space of 1 or 2 years, the use of some of these infrastructures or the land use or the use or the travel itinerary of the set data collected has increased maybe by 20% or 30%. It is through that information we can be able to predict future traffic for infrastructural planning to be able to make adequate planning in the infrastructural growth and development. So, and not just that, it also helps to be able to evaluate the policy impact. When a policy is being implemented, we need to be able to structure, is there an impact as a result of this policy? Are we getting a negative impact or a positive impact based on the travels or based on the transportation system within that city? Most especially when there is new transit lines or tolls, understanding, is it having any positive effect, or is it having a positive or the required effect when it comes to the travel demand, or when it comes to the use of this infrastructures or new implements or new policies that are being implemented. So this travel demand modeling will help us to be able to evaluate that. And some of the key inputs here is if the population is very important, because it is from the population we are able to extract and to be able to get all this. It is through the population we get the travels, their travel patterns, their travel behavior. I think that is the word I should be able, I need to use, that travel behavior, because the population is talking about maybe the people, it's talking about those who use some of this transportation infrastructures, the land, and some of are living within these demographic areas. And another thing is employment, that is the job, the opportunities that are available for some of the people in that city or in that region. Then the travel survey and network data. So these are some of the key inputs that are very important when we are discussing travel demand modeling. So in the first step model overview here, the first one we have is trip generation. And here the simple question is, how many trips are generated? When we're looking into the trip generation, it helps us to be able to determine the daily trips that takes place within a region. What is the total number of trips that takes place within a region? So their ability to be able to gather that is what we call the trip generation. And it helps to estimate the number of trip ends produced in and or attracted. So every trip is made up of two trip ends. That is one at the production end of the trip and another at the attraction end of the trip. So that is under trip generation. Then the next concept or the next step would be the trip distribution. And under the trip distribution, in which I believe the simplest way I can put it is just the beginning and the end of the trip, talking about the origin and the destination. We are going to be looking into various aspects under this later on in this video. But one thing is we need to understand is the trip distribution has to do with the origin and destination. So we need to have that in mind when looking into the trip distribution. Then the next one is what we call the modal choice. Is the modal from the word itself, it shows how we determine the mode of transportation we will be using, most especially if you're going through the highway. Are you driving alone or are you going to be using a share ride? And if you are going through transit, is it going to be based on work access? Is it going to be on any other forms of access, or are you going to use a bicycle or will you use a car? So there is a lot of choices here, and there are other mathematical modeling that needs to be done to be able to arrive at a decision from the use of the travel demand modeling. And that is another aspect we're going to be looking into. And the last part here is the assignment. So the main idea behind the trip assignment is the ability to be able to determine the routes the travelers decide to choose to reach their destination. So which route, based on the information, based on the calculations, based on our analysis, then which one do we think the traveler should choose in order to reach their destination? So all these things are very much important when we are looking into the traffic and the travel demand modeling. And these four steps model these four steps are very important. in the process of doing that. Okay, so this is just also another view of everything I already explained. We have the trip generation, that is the number of trip produced or attracted per zone. Per zone can be per region, per city. And we have the trip distribution, looking at the origin to destination. Origin is where the the travel is beginning from. Then we have the destination where it ends. Who travels where? That it should be able to answer the question. Then we have the modal choice, more choice, talking about is it using car or transit, is it bike, is it work split. So that is another part in which you also have to take into consideration under the more choice. And the last part is the trip assignment, or we call the traffic assignment. That is the routes on network plus congestion level. So the inputs from the here is the land use and population data. Going through all these four steps, then the output will be the traffic volume, the mode share, and also the evaluation. Now looking at the first one, that is the trip generation. That's the first step. We know it estimates the number of trips originating or ending in each zone. We already explained that. And there are two methods involved in doing this calculation. We have what we call the cross classification. That is when you take into consideration the attributes, the characteristics of each household, of the household. And what are some of the characteristics of household? We need to look into their income. We need to look at the age. We need to look at the number of cars. We need to know the number of people in that household. A family of three cannot be compared to a family of seven or a family of 10. So these are basic classifications, and all these classifications are very important under the cross classification based on the household attributes. And the next one is what we call the regression model, that is taking the trips not from for us to be able to determine the trips is usually based on the population and employment. We believe that employment, yes, the population, but they believe that the number of people who are employed within that region will greatly determine how trips are being generated within that particular zone or that particular region. And some of the metrics here is we have the trip rate, that is trips per household per day, taking that into consideration. And here is the formula based on the the trip generation based on the household and the jobs. So there here is just a table showing the trip generation based on land use type, the unit of measure, the trip production, the trip attraction, and here is the source where these informations are gotten from. For a single family residential, we have a dwelling unit, and from here we could see that they have this trip production per day of 9.5 trips, and the trip attraction per unit is about 0.5. Then for the apartments, 6.2, retail commercials, 3 trips per day, then office buildings, 1.2 trips per day, then university campus, 2.8 trips per day. And here are just some of the breakdowns of it. So from here now, there is an example says we should calculate the total trip for a 200 unit apartment complex and an adjacent 50,000 square feet retail center. So, in order for us to be able to calculate that of the apartment, we know that there is a 200 unit apartment complex, that is 200 units. Coming back to the apartment here, that is high density, we know that the trade production per unit is 6.2. So we've been able to multiply the 200 units, since one unit of an apartment is 6.2 trips per day. Then when we take into consideration 200 unit apartment complex, when we multiply by 6.2, which is the average per day, then we'll be able to arrive at 1,240 trip production within that. And for the second, which takes into consideration the retail, that is when we have the 50,000 square retail, then we have to equate it with that of the retail here. So 42, then we multiply to be able to get 2,100 trips as an attraction. So here is just an example on the trip generation. Now, the second one is talking about the trip distribution, and here we know it matches the trip origins to their destination. So here we have the methods we can see which is being represented there, but a broader view of it is what we have here. Now, when we have the origin, the destination, so the origin and the destination is here. So within the movement from downtown, so there can be a movement from down to downtown. So maybe the from downtown to suburb is maybe about 1,200 trips. Then from downtown to suburb B is about 800. So that means the total production of movement within downtown, talking about having the origin of downtown, is about 2,000. Then for suburb A, that is to downtown, is 950. There won't be anything here because there can't be a movement from suburb A to suburb A. So then we have suburb A to B, we have 650. The addition of these two will give us 1,600 as our total production. Then we have that of B to downtown is 1,100. Then from B to A, we have 400. The addition of this is 1,500 because there can be a movement between these two. So here, the total attraction. We have the total attraction and total production. This is the production, and here is the attraction of 2,050. The addition of this 1,600 and 1,450. So when we had all our total productions and we had our total attractions, it will give us a total checksum here of 5,100. So here we can see the rows from that is the trip production, that is the origin. Then the column there represents the trip attraction, which is the destination, in which we already explained. Then the matrix balance is about 5,100, in which we have here. That is just the the matrix balance. So no. Here there is a question which says, why does downtown attract more trips than it produces? Now here's downtown. It attracts more trips than it produces. The reason why it attracts more trips, you can see the attraction of going to downtown, we have 2050, and it's only giving out maybe 2,000. So it's attracting more than what it actually produces, and that might be as a result of maybe employment center in that particular region, where which makes it quite possible for it to attract more. That is, people tend to go there for work, maybe for recreational activities. It can be anything, but if from here we can just say it might be as a result of the employment center drawing commuters to downtown. That is why it tends to have more attraction than it produces. Then the third point here, we have the mode choice, that is the predict travel mode. So is it going to be the use of a car, or will it be the use of a transit, a bike, or a walk? So this can be done using different methods. We have the logic model, which is quite common, and we have the factors taken into consideration: the cost, the time, the comfort, and the reliability. So if I am someone who takes costs very seriously, then it will have a bigger effect on whatever choice I will be making. And if I am so conscious of time, I have to be I have to be in leaving Lagos to Abuja tomorrow, and I have to be in Abuja as early as 8 a.m. So considering that, cost might not really be much of help in this case, because I am running against them. I have a time, I have a deadline, I have a time limit to my movement for that travel. So I will prioritize time over cost, and maybe possibly over comfortability and reliability, because of the urgency of what I have to do in that location. And if the reason why going on that travel is maybe for leisure, for relaxation, then I will have to pick more of the comfort, because that is the idea. I am not racing against time, and cost is not really might not be much of a factor, but the comfort of that trip might be one beautiful or important thing. And the reliability, also ability to know that yes, there won't be any form of delay, or it's it's reliable. So these are some of the factors that might be might take into consideration when deciding or predicting a travel mode or the travel mode in which it can decide to opt for. And here it says how congestion pricing shifts mode share from cars to transit. So here we're going to be looking into. So here we can see the mode choice for cost one. Then this is the percentage based on cars, the probability of bus and probability of bikes use having different costs. So the probability of taking any of these at this prices. Here we have when it is $1, you have 68%, here 25%, and here 7%. But when it is the cost is $3, we have 42%, 45%, and here it's about 13%. And $5, 22%, 60%, and 80%. So there are a lot of calculations here, but we're just looking into the basic explanations involved in this. And the fourth step we have is what we call the traffic assignment. That is assigning trips to transport mode route. So here we're able to determine the route to take. And under this we have the various methods. We have all or nothing. That is the shortest path only. Already did a video on this under graph theory before. Maybe you can check for graph theory video on this channel. Then we also have the user equilibrium wardrobe principles, in which we've also done the same. And here some of the softwares in which you can also use is you can use a Visum, you can use a Transcard or HEM. So these are some of the softwares that can be used as part of the method under traffic assignments or trip assignments. So still under the trip assignment, we have here before the construction of a bridge. So we have two routes. We have the route one and we have the two. The location is a city center bridge, and here is the downtown bypass. So based on that, we have about 4,000 vehicles per hour plying that road, and the congestion, there's usually congestion, and this takes about 25 minutes. So that means there are two routes for that particular road. If you want to pass through that before the introduction of the bridge, there are two. The route one takes about 25 minutes. There's usually congestion because as a result of the vehicles per hour, there's about 4,000. But for the two, it has about 2,500 vehicles and about 18 minutes when it comes to the traffic timing is about 18 minutes. Now, when we decide to introduce a new bridge, we know definitely the introduction of a new bridge will bring about, it will reduce the traffic volume on these other two routes and concentrate, and there will be a little concentration on the new route. Here we have the route one now. Instead of 4,000, it has reduced to 2,800, and the reduction is by 30%. So previously it takes about 25 minutes, but that time has been reduced to 18 minutes. Then for the second route, which has about maybe 2,500 vehicles, now we have 2,200. The 12% reduction, and instead of 15 minutes, it takes, instead of 18 minutes that we spend on that road before, now it takes an average of 15 minutes. Now for the new route here, which is the East River Bridge, there will be a movement of around maybe 1,500 vehicles per hour, and this will be within a space of 12 minutes. So we can see that it helps to decongest the route one, majorly the route one, which is usually congested and takes a lot of time, about 25 minutes. And this new introduction of this new bridge has helped to be able to decongest the route one, reducing the number of vehicles plying that route or the traffic flow on that in that location, and also reducing the travel time in that location. And this helps to be able to create an even movement, and it just makes it a little bit much more even when it comes to the timing and the number of vehicles plying those locations. So here we have, why doesn't Route 1 traffic drops to zero, and what are the limitations? So when we look at this Route 1, even though we know the number of vehicles is about 4,000 vehicles per hour and is usually congested, with over 25 minutes. But after the introduction of the new bridge, it's dropped, and we have a new travel time of about 18 minutes. But the question is, why is it that it didn't drop to zero? Now, there are some other factors that needs to be taken into consideration why Route 1, because that is usually a congested road. So the introduction of a new route means that people tend to concentrate more on the new road rather than focusing on the old one when they know this road is usually congested. I just try to imagine a place in Nigeria right now, because when you're traveling from the mainland to the highland and you're passing through the third mainland bridge, we know very well that that road is usually congested in Lagos, Nigeria. It is always from Monday to, let's just say, Monday to Friday is usually congested, because the number of traffic volume, the number of the traffic volume on that road is usually on the high side. Due to that, is more like the possible route you can take from the highland to the from the mainland to the highland. And also, a lot of people tend to work on the highland, and most of them live on the mainland, so they travel from the mainland to the highland for work, and that makes the traffic volume on that road quite high. Now, looking at that, if a new route is being created, it does not mean that everyone will automatically focus on the new route. Some of them will have this, there is something we call uh, personal preference. So this can also be under this. Why doesn't Route 1 traffic drops to zero? It might just be a personal preference. Some people believe in, they are not, they don't adapt to change easily. So when they know that this is the road I take, I prefer taking that road. Yes, there is a new road, but I'm used to this road. So some people are not liable to change. Some people don't just like the idea of change, so they tend to focus on their old way of doing things. Another thing can be what we call a residual demand. That is when there is only a particular thing that can be done on that particular in that particular market or in a road. There are some reasons why traffic or the Route 1 traffic didn't drop to zero, because there might be a demand, or there might be something that can only be met on the Route 1, which might not be in Route 2 or Route 3. We know there are a lot of people that when they are leaving their origin to their destination, they drop by in some places, maybe for one or two things, maybe for breakfast, maybe in order to pick up friends, in order to do this and do that in the process. And the moment even with the introduction of the Route 3, they will still stick to Route 1 because of some other activities they tend to engage in the in on that route. So that is one of the reasons why we won't see the Route 1, even with a high level of congestion, drop to zero, or the whatever minimal level we are imagining. Another thing is also, maybe it can be in form of destination proximity. Destination proximity, in sense of some people decide to go through Route 1 because they not everyone will spend that a number of minutes on that road. Some people have this the belief in, they know that they are much more closer to their destination when they go through Route 1 than maybe through Route 2 or Route 3. Even with the introduction of the new route, and we could see the travel time reduced to 18, 18, and 12, or 18, 18, and 15, or 18, 15, and 12. Whichever way it is, we still see them sticking to Route 1, maybe as a result of their destination proximity. So there are lots of reasons why Route 1 traffic will not drop to zero. And also, there is something where people believe that when there is a new road, yes, some people really like the idea of new things. They want to try what is it like all about. And some people also have it at the back of their mind that due to the introduction of this new route, people will tend drivers or road user will tend to focus more on the new road and leaving the old road, which is the Route 1, and using the Route 3. And that makes some of them decide to stake in, knowing fully well that the traffic volume or the congestion on that road will drop. And in the we could see that in the diagram here, how it drops with the introduction of the new route here, the Route 3. We can see the introduction of it and how the vehicle numbers dropped, and also have an effect on the travel time. So basically, looking at this, if you want to plan a new subway line in City X, the first thing is looking into the trip generation near the station. So what is the movement from within that station? So that will help us to determine And from that, we'll be able to move into the distribution to downtown jobs, looking at the job opportunities, the employment opportunities within. And furthermore, we'll look into the mode shift from cars to transit with the introduction of this new subway line in City X. Then from there, you can assign reduced traffic to roads. So this is just a simple plan, though there are a lot of mathematical and conceptual framework that is embedded in which we are not looking into in this video. But this is just to give a little breakdown of the concept of travel demand modeling. Thank you, and I'll see you in the next video.